In this video, we're going to evaluate the following integral using the substitution u equal x to the 1/6. Now, using this substitution, we want to find a representation for the square root of x in terms of u. Well, notice if I cube both sides here, I get u cubed is equal to, and if I cube this, 3 over 6 is 2, 1/2, that gives me the square root of x. If I square both sides of this substitution, I get u squared. You square this, 2 multiplies to 1/6, I get 1/3, x to the 1/3. Of course, it's cube root of x. And of course, eventually I'll get a representation for dx. So this is what we have on the left over here. There's my substitution, u equal x to the 1/6. Take both sides to the 6th power, I get x, and then from that I get dx. Cube both sides of this, I get u to the 3rd is equal to x to the 1/2 or the square root of x. Square both sides, I get u squared. Square the x to the 1/6, I get the cube root of x. So this is what I'm going to substitute into this integral here. So this is going to equal to, now this has a power of -1. So I'm just going to take this to the denominator. So this can be written then as dx on top, and then square root of x in the bottom plus the cube root of x. But I know the substitution for dx, so I'm just going to put it here. 6 u to the 5th du. Know the substitution for the square root of x, that's u cubed. Know the substitution for the cube root of x, it's u squared. Okay, so square root of x is u cubed right here. Cube root of x is u squared is right here. And of course the dx right here. Now let's simplify this integral here. It takes the form of a rational expression. Notice I can take out a u squared from the denominator and divide it into the numerator. So this numerator will simplify into 6 u to the 3rd du. And then the denominator will have, because we factor out the u squared, the u to the 3rd becomes u. So this is u squared times u plus 1, but we divide the u squared into the u to the 5th, and it simplifies to that. So the integral then simplifies to 6 u to the 3rd du over u plus 1. We don't want to consider partial fractions yet, so let's just take this long division. Since the degree of the numerator is larger than the degree of the denominator, let's just write this as 6 u to the 3rd, and that'll be divided by u plus 1. So it goes u into 6u to the 3rd. Move it over here a little bit, so this will be 6u squared. Then I multiply times the divisor, so this will be 6u to the 3rd, and 6u to the 3rd times 1, or to the 2nd, I should say. And then we subtract. Just doing long division, so these terms can cancel. 6u to the 3rd minus 6u to the 3rd, and let's look at this as 0. 0 subtract this will give you minus 6u squared. And as long as the degree of the remainder is larger than the degree of the divisor, we can keep going here. So divide u into minus 6 here. It gives me a minus 6u. Multiply minus 6u squared minus 6u. Subtract. This cancels out. Again, 0 here minus the minus 6u gives me a 6u. Again, degree is the same. Degree 1 for the remainder and the divisor, so I can divide again. So u into 6u will give me a plus 6. Multiply 6u, or 6 times u is 6u, and 6 times 1 is 1, or 6 rather. Subtract here, 6u minus 6u cancels. And then 0 minus 6 is a minus 6. So I can come back up here and then say this is equal to, so let's replace this then. This will be the integral. Let's take the quotient over here. This is a 6u squared minus 6u plus 6. And then here I have the minus 6. So that's a minus 6 over the divisor, u plus 1, I should say. So we get that. And that's du. So we simply took this expression here, using the long division, we simplified it to this 6u to the 3rd over u plus 1. Then we did long division, and the quotient to this was 6u squared minus 6u plus 6. Remainder was minus 6, so that goes over the divisor. Let's just move it over here then. Equals to, then we just do the integration here with respect to u. So this is going to be 6u squared. Well, we add 1 to the 2 because we're integrating with respect to u, so this will be a 3 here. This is over 3. And it's minus 6u squared. Adding 1 to the exponent. Then dividing by that. And the plus integral of 6 with respect to u is 6u. Then we have minus 6. And then just, you can think of this as du over u plus 1. That's just the ln of absolute u plus 1. So that's really your answer in terms of u. 6 over 3, of course, will be 2. Minus 6 over 2 will be 3. And then we just got to go back and replace what u is equal to. U equal x to the 1/6. So let's go put the final answer over here. This is going to equal 2. So this is going to be 2. And then u to the third is the square root of x. And again, the next one, minus x over 2, that'll be a minus 3. And u squared over here is the cube root of x. And we have a plus 6 and u, x to the 1/6, so you can write that as the 6th root of x. And then the last term here is minus 6, and it's ln, and absolute value of u plus 1, but u is equal to x to the 1/6, so we're going to need parentheses here. It'll be positive. I'll just write this as the 6th root of x plus 1. And it's plus the constant of integration. So the final answer here, so it's 2 square root of x minus 3 cube root of x plus 6 6th root of x minus 6 natural log, and then in parentheses 6th root of x plus 1 plus the constant of integration. Thanks for watching. We'll see you next time.